Hello students, welcome back to the class. You know what time it is?
It's math time, ma'am.
Yes, and in today's class we will be learning equivalent fractions followed by how to reduce a fraction into its lowest term. So let us start. You can see this is one rectangle. You can take it as one whole. Now dividing this one whole into two parts. So each part becomes 1/2. This is 1/2. This is also 1/2. 1/2, which is 1/2. Now same rectangle is drawn below. Dividing it again into half. Both the portions are 1/2, 1/2. Dividing it further from the center. How many parts it becomes now? 4 parts. So each part is 1/4, 1/4, 1/4 each. Now you just see this 1/2. In the next figure, second figure, this 1/2 has become into 2 times 1/4. That means 1/4 plus 1/4. This same measurement, same size has become 2 parts as 1/4 plus 1/4. It becomes 2 parts out of 4. One part, second part. So 2 parts out of 4. Now same measurement going into the third picture, third diagram, making into 2/2. Now it is 1/4 each. Further dividing it into, now check out how many parts are there. 1, 2, 3, 4, 5, 6, 7, 8. Same figure being divided into 8 parts. Each part is 1/8. What we are visualizing? Half. This is 1/2. Here 1/2 is divided into 2 parts of 1/4. Now in the third figure, 1/2 is divided into 4 parts of 1/8. So it is 1 time plus second time plus third time plus fourth time. 4 parts. Same 1/2 is now divided into 4 parts of 1/8. It becomes 4 parts out of total 8. Total 8, out of that 4 parts. So here 1/2 same box is equal to 2/4. This same box is further equals to 4/8. Thus, here we can observe 1/2 of the first figure is same as 2/4 of second figure. Further, 2/4 is same as 4/8. Thus, this equal part is only divided. This half is only further divided into equal parts. So, this is called equivalent fractions. 1/2 is equal to 2/4 equals to 4 parts out of 8. These are equivalent fractions. So, this is how we have understood with the help of this diagram. Now, let us try to understand same with the help of question. Suppose you are having one fraction 1/3. We have to find the equivalent fractions of 1/3. 1/3 multiplied by second fraction we are finding, so multiply by 2. 1 2s are 2, 2 3s are 6. 2/6 is the second equivalent fraction of 1/3. If we have to find third equivalent fraction, multiply by 3. It becomes 3/9. Fourth equivalent fraction 1/3 multiply by 4. Numerator and denominator both equally we are multiplying it. Numerator and denominator both, it becomes 4/12. Thus here you can observe that given fraction 1/3 is equal to second equivalent fraction 2/6. Further equal to third equivalent fractions 3/9. Further equal to fourth equivalent fraction 4/12. So this way we can find the equivalent fractions multiplying the given fraction by the same number, numerator and denominator both. After understanding the concept of equivalent fractions, let us do some of the examples. First example, 3 upon 4. We have to find first 5 equivalent fractions. When we talk first 5, then multiply by 1 gives us first, multiply by 2 gives us second, so on. Now, we never multiply the fraction by 0 because multiplying by 0 you will get 0 only. So, first equivalent fraction multiply by 1 gives you same fraction 3 upon 4. Second equivalent fraction multiply by 2 you get 6 upon 8. Third equivalent fraction multiply by 3 you get 9 upon 12. Fourth equivalent fraction multiply by 4, numerator and denominator both, so you get 12 upon 16. Now fifth equivalent fraction, so you have to multiply by 5, 15 upon 20. So thus you can say 3 upon 4 has equivalent fractions 6 upon 8, 9 upon 12, then 12 upon 16 and 15 upon 20. Now suppose in this B part the question is asking you to find 3 equivalent fractions of 4 upon 5. Not first 3, any 3. So here we got the choice and the liberty to find any 3. The given fraction is 4 upon 5. If somebody multiply it by 2, the child will get 8 upon 10. If another child wishes to multiply it by 5, directly by 5, yes, we can do because question has asked us any 3 equivalent fractions. So 20 upon 25. Another child wishes to multiply it by 10. So it becomes 40 upon 50. So here 4 upon 5 is equivalent to 8 upon 10. Then 20 upon 25, then 40 upon 50. So by the first two examples, we have understood that we can find the equivalent fractions by multiplying numerator and denominator by the common number. Now let us see, we can find the equivalent fraction by division method also. 8 upon 12, 8 upon 16. If we multiply it by 2, numerator denominator both, yes, you will get the equivalent fraction. Same ways you can use the division method also. Divided by 2. 2 4s are 8, 2 8s are 16. So 4 upon 8 is the equivalent fraction of 8 upon 16. Same ways further you can see the common table divided by 4 if we do. 4 2s are 8, 4 4s are 16. 2 upon 4 is also equivalent fraction. Let us go further. We can choose the table of 8 also. 8 1s are 8, 8 2s are 16. So these all are also equivalent fraction which we have got by dividing the given fraction by a common number. So thus 8 upon 16 is equals to 4 upon 8, further equals to 2 upon 4, further equals to 1 upon 2. Okay, let us do the next sum. 50 upon 100. One can divide this fraction by 2. It gives us 25 upon 50. Second child can think that I will be dividing it by 5. So yes, this can also be done. 5 10s are 50. 5 20s are 100. One may can do 50 divided by 10 because both the numbers are divisible by 10. So 10 5s are 50, 10 10s are 100. Okay, now we can choose further common table of 50. So it becomes 51s are 50, 52s are 100. So here you can see we can find the equivalent fractions by multiplying the given fraction, numerator and denominator both by a common number and dividing also by a common number. The thing that you have to take care that the fraction should be divisible by that common table which you are choosing. So yes, 50 upon 100 given fraction is equals to 25 upon 50, further equals to 10 upon 20 further equals to 5 upon 10, and which is further equals to 1 upon 2. I hope the concept of equivalent fractions is clear to you. Now, after understanding the concept of equivalent fractions, let us see how to reduce a given fraction into the lowest term. The first fraction 8 upon 16. So method is, the first method which I am telling you is the HCF method. Here what we have to do, we have to find the HCF of both the numbers, numerator and denominator both. So write down the numbers 8 and 16. Common table, only prime numbers, both are even. So 2 4s are 8, 2 8s are 16. Further, even numbers divisible by 2, 2 2s are 4, 2 4s are 8. Again these two are even numbers divisible by 2, 2 1s are 2, 2 2s are 4. So what is the HCF? For HCF we have to take only the standing line numbers. So HCF equals to 2 times 2 times 2 equals to 8. Now the method says we have to find the lowest form of the given fraction. That means the given fraction we have to divide by HCF. 8 upon 16 to be divided by the HCF. What is HCF? 8. So 8 ones are 8. 8 twos are 16. 1 upon 2 is the lowest form of 8 upon 16. Going to the next sum. 12 upon 18. Both the numbers, let us take the HCF of 12 and 18. Even numbers divisible by 2. 2 6 are 12, 2 9s are 18. Common table. 6 is even number divisible by 2, but 9 not. But 9 is divisible by 3. So is 6 also divisible by 3? Yes. So that means we can choose the table 3 here. 3 2s are 6, 3 3s are 9. Now 2 and 3. Any common table? No. 2 and 3 are co-prime numbers. So here only we will leave them and take the standing line numbers. HCF equals to 2 times 3 equals to 6. So that means 6 is the highest common factor, the number by which the given fraction will be fully divisible. Let us divide 12 upon 18 divided by 6. Table of 6. 6 2s are 12. 6 3s are 18. So 2 upon 3 is the lowest form of 12 upon 18. You just see here the remainders which we are getting. In place of 12, we got 2. So yes, in place of 12, we got 2 as numerator. In place of 18, we got remainder 3. So yes, in place of 18, in answer also we got 3. So 2 upon 3, remainders, same. What remainders are here? Same is the answer. Check out in the first example. Remainders are 1 and 2. Same is the answer, 1 upon 2. Okay? You can check your answer this way also. Going to the next sum, 15 upon 20. Let us do the HCF, common table. 20 is even number divisible by 2, but 15 not. 15 is divisible by 3, but 20 not. Which is the common table? 5. 5 3s are 15, 5 4s are 20. No other common table. 3 and 4 are co-prime numbers. So HCF equals to 5. That means given fraction we have to divide by 5. 5 3s are 15, 5 4s are 20. 3 upon 4 is the lowest form of 15 upon 20. Check out the remainders in the HCF. In place of 15 we got 3. Yes, numerator is 3. In place of 20 we got remainder 4. Yes, here also. In place of 20 we got denominator 4. Let us try next sum. 18 upon 30. Let us find the HCF of 18 and 30. Common table, both are even. 2 9s are 18, 2 15s are 30. Now none of the number is even, so we have to leave the table of 2. Going to the table of 3. 3 3s are 9, 3 5s are 15. Any common table for 3 and 5 both? No common table. That means they are co-prime numbers, no common table. So HCF will be only standing line numbers. 2 times 3 gives us 6. Given fraction divided by 6. 6 3s are 18, 6 5s are 30. So the answer is, the lowest term of given fraction 18 upon 30 is 3 upon 5. Let us check from the HCF. In place of 18 we left with 3, so numerator is 3. In place of 30 we left with 5, so denominator is 5. So this is how we find the lowest form of a fraction using HCF method. Now second method which I am going to tell you, after HCF method there is one more method which is called cutting method. It is also very easy and interesting. I am taking the same numbers. The fraction here 8 upon 16, A part 8 upon 16. So here how we are going to do the cuttings? We have to think the common table for numerator and denominator both. 8 and 16 both are even number. I am writing the fraction one more time. 8 is divisible by 2, 16 is also divisible by 2. Equally proportionate, equivalent fraction dividing by same number numerator and denominator both. So table of 2, 2 4s are 8, 2 8s are 16. One time numerator cut, one time denominator cut. Now we got 4 upon 8. 4 upon 8 again even numbers divisible by 2. Again table of 2, 2 2s are 4, 2 4s are 8. Second time numerator cut, second time denominator cut. Again 2 upon 4 are even numbers divisible by 2. 2 1s are 2, 2 2s are 4. Now 1 upon 2 is the final answer which cannot be cut further. So this is how we have done the cuttings. Think of a common table by which the both numerator and denominators are divisible. Then start cutting. One time numerator, one time denominator. Another factor you find, then again second time numerator, second time denominator. You have to go equivalent. 2 times numerator cut, so then 2 times denominator should also be cut equally. So here the HCF was 1 upon 2. Here also HCF is 1 upon 2. Let us see the next B part. 12 upon 18. Let us try the cutting method here. 12 upon 18. Common table 2. Why? Because both are even numbers. 2 6 are 12. 2 9s are 18. One time numerator denominator both cut. Now 6 and 9 don't come in the table of 2 but they come in the table of 3. 3 2s are 6, 3 3s are 9. Second time numerator denominator cut. Now 2 upon 3 are co-prime, don't come in any common table. So 2 upon 3 is the lowest form of 12 upon 18. Same answer here, 2 upon 3. Same answer here, 2 upon 3. See the next sum, 15 upon 20. Fraction given. Let us do the cuttings of 15 upon 20. 15 is odd number, 20 is even number divisible by 2 but 15 not. Go to the table of 3. 15 is divisible by 3 but 20 not. Go to the next table. Yes, both the numbers are divisible by 5. 5 3s are 15, 5 4s are 20. So the fraction lowest term is 3 upon 4 as 3 and 4 cannot be cut further. So 3 upon 4 is the lowest form of 15 upon 20. Tally here. It was 3 upon 4. Here also 3 upon 4. Next sum D part. This you all have to try yourself. Cutting method. See. Both are even number divisible by 2. So start doing and tell me in the comment section that have you got the answers. I hope you have understood the concept of equivalent fractions. Then reducing the fraction into the lowest term in two ways, HCF method and cutting method. Keep practicing. Thank you. If you have understood the concept, ensure to like the video and subscribe to my channel. Maths Time by Alka Ma'am. Thank you.